Thanks everyone for being here. Sorry we're a bit late. We had a little issue with the internet first. My name is Thiago, and talk is between me and Francis, and we're going to be talking about the process of making digitally before we actually make it for real. So it's a visual prototyping discussion. So Francis is a designer. My name is Thiago. I'm the founder of Lagoa. So the company builds a software for visual prototyping, and we just launched very recently, and we started seeing some interest from fashion designers and people that are trying to visualize things before they make it, and they try to visualize a real version of it before it's actually produced, because there's a cost process. So my background comes from the digital industry. So I was working in visual effects and 3D and entertainment products, and I was a creator myself for many years, and I'm just now getting into 3D printing, and with technology I'm trying to help Francis to build his things.
Yes, and I'm a designer. My name's Francis Batanti, run a design studio based in Brooklyn. I trained originally as an architect, and I now run an interdisciplinary design studio. I have a background in CGI, engineering, and design. And we'll show some of the work today, but visualization's a very important part of the work. We work entirely digitally. We work mostly with new modes of manufacturing, including 3D printing. We were just talking the other day, the work really goes from simulation to production, and that the role of drawing now in design is really one of simulation.
So this is a new industry, so there is not very well defined boundaries of how the process should be, how the model should be built, how the final product should come out. So traditionally in CAD, in design, you have a very defined process. You have a CAD software where you build the models, and that's using 2D planes normally to construct the primitive. And at the end, you get it milled, or you get it extruded, you get it made somehow. That process is completely changing with 3D printing, and the reason is because you can get anything, and you can get to a print from anything to anything, basically. So the maker process is very different. So traditionally, this CAD software like AutoCAD or SolidWorks that build geometry, they're all built for exactly for that, to build 2D geometry and then get to a 3D model. Today is basically, like in the case of Francis, the simulation is a very important case. So he can talk a little bit about how that works for him.
Just switch it over.
Yep.
Okay.
Now you're gonna see some pretty pictures. Come back.
Let's come over here.
The other one.
The other one. There we go. Okay.
Is it on?
Are we on?
Is it out there?
There we go.
So the process of simulation is basically the process of using time to actually create a model. So that's what Francis uses a lot to design his projects.
Yes, exactly. So like I said, I have a background in CGI as well as architecture. And what we generally do is we work through computer simulations to find new and novel formal organizations and arrangements. So I don't like to say that we produce drawings. I would say we produce systems, we produce simulations, and those systems and simulations generally have a high level of abstraction. This bundle of sticks, believe it or not, eventually becomes a chair, right? But there's no sense of materiality. And one of the biggest hurdles in the studio is, how do you deal with all this geometry, all this data, and how do I visualize it in a way that's meaningful for my practice, which is really involved in putting the virtual into the physical world, right? So I have to move a drawing, I have to move an abstraction into material. So what I need is a tool that creates an interface between my drawing and those benches you're sitting in now. So the work started out very abstract, and it was really just drawing. We were really struggling to build and materialize a lot of these things early on. But we saw an enormous amount of potential in the production technologies that were coming, and in the ways of drawing and managing that data. Finally, in 2007, the studio built its first project. This is a bicycle rack for the New York City Department of Transportation. And the thing I love about this image is that it looks like a computer rendering. And like I said earlier, I work with I work with polygons, I work with media, I don't work with materials, right? I sculpt this in a digital environment. So the early work was so heavily informed by my understanding of what I would consider to be a digital materiality. And the early work really became all about materializing things in car paint, right? So it was really, the aesthetic at this stage was really because I had poor visualization tools. But it was something that, you know, it made the work what it was. And I still think there's something really important in the aesthetics of that environment. So this is the piece being 3D printed. All the parts were directly 3D printed on large 3D printers that are used to print car parts. And then they were finished with an automotive paint, right? But this is the part of the process that the computer has a hard time simulating. And very often, you know, you produce geometry and you produce output, but I don't know what I'm getting into when I start the material process. And I think at this stage we had poor visualization tools, but had we had better tools, we might have actually used real materials. So anyway, after we built our first project, I became much more interested in materializing and creating objects. I wasn't interested in drawings anymore. So I was wondering, how could I take these are abstract drawings. They're generated computationally, they're generated from algorithms. They have nothing to do with physicality, but they're processed through tools that are digitally controlled. This is a CNC routed mirror, and we mapped these algorithms into the tools in order to create contours and deflections in the surface. And these are all things that need to be anticipated by a designer. You need an environment where I know what the ramifications are of the decisions that I'm making before I make them. Prototyping costs can be very expensive and timely.
So on this case is that chance that we're seeing here, the chances are you're gonna start doing this, you're gonna be seeing this shaded 3D view, and you're gonna have no idea what the final product is gonna look like until you actually get there and you produce it. So that's what we're trying to break the boundaries, is see these things before they are actually made. It's very hard to say what something looks like without rendering first.
Right, so this is a visualization, this is a sample of the material, right? I mean, the renderings are getting better and we're getting closer to the materials. There's less surprises. I know what I'm working with. This is a dress that's kind of fascinating, actually, when you see moving it. There are all these joints and parts, and this case specifically was very interesting for us to bring because he never saw the dress before it was made. That's right. So there was so much geometry in this dress. This was all I saw before I sent the parts to the fabricator. I did not have enough power locally in the computers in the studio to visualize the dress in its entirety. I could see pieces, but this was about the best I could do. So it was really a leap of faith to send this out. One of the great things about Lagoa is it's a cloud-based platform. So I can render this. You need many machines to render things like this. And that's a lot of overhead for a small studio to carry. So Lagoa is a really excellent platform for really outsourcing the computing power that we need to visualize a lot of these projects.
Should we jump into the...
Yeah.
Okay. So now we're going to show you guys a little bit of how that process is taking place in a Kieran project. And the interesting part is that now we got the technology and we got the compute power on the server. So I'm running a MacBook Air over the internet, and what I'm going to be doing is essentially just loading up a 3D scene that has a 3D model, and I can make a decision directly visually what materials I want to see or what materials I want to print this on, and that process can be very costly if I'm doing this in my computer. So this is just a web browser. There's no installation here. We just opened this over the web. We're running over Wi-Fi, and this is a model that Francis is working on. And here we can see it from all angles what the model is going to look like. And essentially we had no. This is a floor. Got on the way.
Lost the sign.
We lost the sign?
The sign.
Oh. What happened?
TV's out.
Oh. Well, Oh, this is the sky. Okay.
Okay.
So this one has an environment, which makes it a little bit more interesting as well. But just going through the process here. So this is the model. So this came out of a simulation, I assume, or some kind of algorithm design tool. And here we can make a decision if this is going to be gold. We can just say, show me this object in a gold version, and I have a gold version of this. And that allows me to make the decision if this is really the material, the final material, or this is the material that we want to see this object when we print it. And we can look at it from all angles. We can make we can make assumptions about the material, but you also can make assumptions about what the user is gonna experience when he sees this live.
Right, and from my perspective, this lets me know maybe I need to change the cross section. I need to have just slightly different angles to catch the light differently. By the time I get to the first prototype, I'm much more informed of what the actual experience of the thing is, and I'm not just taking a guess or a leap of faith from a drawing. The other thing that this allows us to do is realize scale differences, which is a major part of the printing process. So if this thing was bigger, the color changes. And the reason why the color changes is because the material is a physical material in our system, and the light absorption, so as the light passes through the material, if it's a bigger material, you're going to have more light absorption. It's a small material, the light's going to pass through. So the scale differences are huge, because sometimes you do a visualization and without realizing that a small object is going to be more transparent, because this is all printed in plastic or some kind of polymer that won't have a lot of density sometimes. So that's the kind of visualization that we're talking about. You're able to see all these things before you make them. You essentially can make a choice if this is what you want to make, really, if it's worth spending the time and the money on it, and this can highlight, impact quite a lot the final result of the product that you're working on. We have more examples with more complex scenarios, so just jump on something else. And by the way, this is all free. You can just go online and create an account. So from my perspective, the fact that he's doing this on a MacBook Air over a wireless connection is amazing. The freedom. I travel a lot. I'm able to do these images from a train, a car. It's very portable. It's a lot of power that's very portable.
Let's just talk about the difference quickly. So you look at this shoe in a 3D program, and the model basically it looks okay, but I have absolutely no idea of the final visual. You know what the shape is, but you don't know the visual part yet. So when you start rendering, you start seeing that, okay, if I'm doing this in one material versus the other, I get a completely different result. So that's the kind of power that we're trying to bring to the printing process and to the visual design process. How many of you model here? Do you do models in 3D programs? What programs do you use? AutoCAD? There you go. That's an easy process. But if you were to take a picture of a thing, or if you use some scanning technique like PhotoFly or some kind of simulation software, the possibility is that everything is going to be intercolliding and things are going to be very messy. You're going to have a soup of triangles, and at that point the visuals matter a lot. I'll open something else.
I think we're at 5. They said.
We're 5?
Yeah. We should start questions.
Okay.
Yeah.
So if you guys have questions that we can help answer.
Yeah. What software do I use? We use a lot of different softwares. Predominantly, it's Maya and Rhino, and ZBrush. Quite a bit of ZBrush lately.
Have you released Framework?
I have not. Any?
You said this was a distributed computing model. Are you is your machine being used to have all of your tasks?
That's for you. No.
No, absolutely not. Your machine is doing no work at all, and the process is collaborative. So I could open the scene at the same time that he opens the scene, and we could be connected, and the edits would show up for each other. And the process is entirely done on the server, so you don't need any hardware. You really just need like a computer to load up the web browser and yeah, and you need a model. So if you have a 3D model, you just upload that model. If you don't have a model, you can search for one and you can try to use that. Any more questions that we can help answer?
No.
Well, I would finish by showing you something else that's completely different, but I wish to see printed one day. A person. So this is an eyeball. It takes a little bit of time. The fascinating part of this whole process is this new way of choosing the materials, really, because they are the choices are made completely based on the appearance when you're doing something like this. There we go. So one day we're gonna be able to print a person, and then it's gonna be like this. If we could print 5. All right. Thank you. Thanks very much.
Thank you.